Hi everyone, it's been a while, but I have a report on Turbovac 150, the TMP that we have rebuilt in 3 previous series. So, and also I did not bother to film the beginning, because there was essentially nothing to film, just me bolting the thing in. So, enjoy the slides, I guess. But first, I would like to address something. In the comments, people said that, well, I ruined the pump and stuff. Well, probably I did. That's the thing. That's why the disclaimer is here. You should always consider me stupid. And mentioned in the comments, which was, well, good. I don't mind at all, by the way. So, copying a method without adaptation, without thinking what you're doing, will cause pain, suffering, loss of money, and possibly limbs. Adapt it. So, I do it because I do it the first time. I didn't find any videos of doing how to do the TMP rebuilds, okay? So I had to do it myself. Probably next time, if I will be doing it, I will not be using like screwdrivers to pry it. I will not be using like this abomination of the bearing puller that I used. I will be using something more gentle, so on and so forth. So discretion is advised. Better to say required. Okay, so the second thing is that I finally got the controller. It's this box. It's this box with a wrench on top, and yeah, new one or even the used one is like extremely expensive. So I managed to find one for like around $100 on the auction, which was sold as junk, but after cleaning and like poking at the capacitors, it started up, so it was fine. Also, I had to make a transfer plate from the TMP to the sputtering chamber that we are using, because the sputtering chamber before used the cryogenic pump, which has like extremely huge orifice, and yeah. Also, you can see a few problems with this abomination of transfer plate. First, it's made from, well, ferrous metal. It's not stainless. That's why it rusts. So, I think it's just a poor man's choice. Also, I didn't think much about it because, well, it's inside the vacuum, right? Except for the outside part. Second, in this chamber mostly argon and nitrogen are pumped, so yeah, it will not rust from the inside, it's fine. Also it is shielded from plasma there, so it's fine. However, there is a bigger problem with this abomination, and rightfully so. As you can see, the top of the bolt is inside the chamber, and the bottom of the bolt, it's kind of outside, don't you think? So the problem is that this chamber is intrinsically leaky. It will leak some gas inside, right near the TMP. I tightened the bolts, I filled them with grease, I did everything I could, but, well, I just couldn't make the transfer plate big enough, or like usually it's made from a pipe into plates. I did not have a welder. It's just I did what I had to, and I did what I could. So just keep in mind that this chamber is intrinsically leaky, even though like in the preview it pumped, like you can see from the preview that it pumped to like 2 to the minus 3 pascals, which is not bad at all. Finally, the part I did not film, and I slightly regret it, is the connection of the TMP to the controller. So as you can see on the TMP we have the part on the left, like the circular socket, which has 8 pins. 2 of them is a temperature sensor, one is shorted to the casing, essentially the earth, and there is a 3-phase motor inside. And on the controller you have 10 pins. 2, like on the left, as depicted, go to temperature sensor. This is simple, so if the TMP overheats, the controller will just shut down. Second ones are the grounding pins, they're shorted inside, so they're shorted inside. You can use any of the 2 pins provided. The phase pins, like the motor drive pins, are actually pretty interesting because they're not shorted inside, and instead they're connected to the halves of the H bridge. So the top parts are connected to the top part of the H bridge, and the bottom part is connected to the bottom of the H bridge. So in theory it was possible to just short them out and like get 1, 2, 3, 4, 5, 6 pins total output. But I don't know why they did that. Probably for detecting the cable disconnects, and maybe since it's low resistance motor, it's like 0.6 ohms or something providing. Yeah, most probably it's just done to protect the controller itself. If the cable is disconnected, no current will flow regardless. So here's that. So I guess let's see how the sputtering system works.
Okay guys, so this is going to be the first start of this pump. So as I showed before, the oil is still outgassing a bit, but it's fine, it's vacuum pump oil. This is the controller. I just here and connect it on the back. And this gauge is actual chamber pressure. Like basically this sputtering thing has 2 chambers. So one is vacuum part here, like the cryo pump used to be here, like so the cryo pump is here. It used to be here. So this is this gauge, and the main chamber of sputtering is this one, and the ion gauge is also in the main chamber. So first I want to check if it spins up to, well, 200%. Because right now it's 5 pascals or something, so it's acceptable to start the pump. Okay, now or never. It does shake a bit, but I think it's only the acceleration part. So basically when it goes up to speed, it will switch to normal from acceleration. Oh, you can hear it spinning up. Whoa, 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 look, look, look. See? It was at 5, now it's at 1. Perfect. You can hear the whining. Here you go. By the way, this is the low vacuum part, maybe like 10 pascals here or something. The high vacuum is there. Whoa, it goes. It goes. Nice. Okay. Yay! It's normal! It's normal, boys! We did it! We did it! Okay, now to measure the IG, ionic gauge, not IG. IG is gate current. To measure from ionic gauge now. Okay, let's. So we need to pump this one a bit more. Or actually, I'm not going to do that. I'm going to open the main valve slowly. It's a bad idea. No. Like basically it's the first time of me bringing up this machine. Nice. If it starts heating up, I will notice probably. I'm a bit nervous actually because it's the first time. Like, I legitimately didn't do it before. I do not hear any difference actually in rotation speed, so probably it's fine. Like, basically now I'm trying to drop this, so the main chamber pressure for around 10 pascals, but if I let the main valve leak slowly through the TMP, I believe that it would work. Basically the main valve is here and I'm turning it really slowly to spring a small leak from the main chamber to the vacuum pump. Like, if you do it too fast, it will just explode. I will probably put some pictures in there. I'm sorry, it's like not really obvious what I'm doing right now, but it's extremely stressful because it's the first time I do this on this particular machine. I'm not sure how pump will handle it. I'm not sure how the controller will handle it because this is a, well, I just bought it. It's the first time I'm spinning it up. So this is, come on, give me something. Give me the movement. Give me the movement. And at the same time, I'm closely listening. Any second now. Any second now. Okay, the ion gauge turned on. Like, actually it turns on the same second that the valve is considered open. Basically it has a positional switch, but the actual valve is not open yet. Okay, I feel a difference in movement. Come on. This is the most does it even move? Oh, I think I just over tightened it last time, so it does take quite a bit of turns. Okay. Oops, it was me. Yes, it was me. I was trying to open it slowly. Okay, I'm still keeping this below 10. So basically it leaks from the main chamber. And yeah, basically when this one reaches 10, I will be opening it in full. Okay, time to check the temperature. It's a bit warm on the bottom. Oh, sorry. It's a bit warm on the bottom, but really nothing major, maybe like 30 degrees. It's really well ventilated here. I don't feel any heat from the controller. This is good. Actually, the control MOSFETs are on the side, so I'm also touching that. It's fine. Oh, whoa, I think it's going to work. Actually, in the metal deposition machine, we let it go until 20 pascals, I guess, and then we open it on full. Like basically, we're only opening the chamber to TMP, what they call it, chamber to TMP valve when it reaches like 20 pascals. But I guess we can go a bit harder here. Oh. Yeah, no, I should be more patient. You should always smack yourself on your hands when you try to do something too fast. You will regret it, like, dearly. Like, just take your time. I don't know, spend another like 20 minutes or something waiting. You cannot wait, just like, I don't know, catch yourself or something. But you shouldn't rush things. Never rush things. Everything should come in natural order. Okay, now I think the flow of gas is low enough so I can open the valve more. Yeah. And actually right now I'm looking at the pressure before the pump. Not the chamber pressure, because chamber actually is extremely dirty right now. It stayed open for half a year, like all full of water and shit. Okay. Here we go, we're climbing out there. Nice, almost 20. When it reaches 10, when this one reaches 10, I'm just opening it in full, because 10 pascals is the backing pressure of this TMP, so it can work in 10 pascals. I mean, it will suffer a bit, but it will work. Okay, I think we're good. Yeah, it will do. Almost equal. Okay, go slowly. Okay. Here we go. Main valve fully opened. Nice. This I indeed like. Now I guess to turn the filament. Will it work? I'm not sure. Let's try. No. No, still zero. It's not really good to run the ion gauge that high. Yeah, probably I'm just going to do like this. And we're going to bake the main chamber later. Okay, this goes slightly warmer now. Okay, I think we're past the limit. Too bad I don't have my current sensors here. I want to know how much this thing is drawing right now. Okay, this open, air closed. Okay, will it go below 1? Oh, it's -1 now. Nice. Beautiful. I mean, judging by how dirty the chamber was, and by this tube which was hacked on the side because we needed a more precise flow control, I think it's acceptable. If it goes to 2, well, I'm going to dance right here. Actually, I'm going to dance right here when we start pumping the gas through the chamber. And actually light the plasma inside. This would be awesome. But to start pumping the gas, first we need to heat it up. Actually, I'm going to do the full review of the machine after it's brought up, like, because all the procedures will have to change. Like this is actually a sputtering machine with ordinary cryo pump. Used to be ordinary cryo pump, now it's TMP. And the sputtering pressure is actually around minus 10 to the minus 1, 10 to the minus 2. Yeah, and if I look at the log notes here, yeah, actually it was sputtering around this pressure from the data before. 3, like 2 to the 10 minus 1. Okay, let's see how it goes. I will just heat it up. Actually, let's heat it up together. We need to... Oh yeah. First I need to turn on this, bring up this chiller. Then I will have to bring up this heater. Yeah, so yeah, probably later. Okay. I will keep you updated on the pump. Look, I just turned on the heater. Like, it's still like 20 degrees. Pressure already going up. Outgassing so much. Okay, it's a few days later, and after sputtering, so after causing some plasma to shine inside here, we get this. So the cleanest possible chamber is around like 3 to minus third, 3 to 10 to minus third pascals, which is pretty nice for sputtering. Like the sputtering itself is like 2 orders of magnitude above that, so it's good enough. And yeah, the temperature inside the pump is 38 something. The pump itself is, well, it's fine. I will put another cooler here, and I think we'll be done here. Okay, and this looks like it's the final version of the sputtering setup. I will explain how it works in a separate video, I guess, because it deserves a whole talk on its own. Okay, this is the pump that I, well, rebuilt with my, yeah, crooked hands, I would say. So, you can do it at home, probably. Bye-bye.
Okay, this is probably the final word on this TMP series. You can see the silicon wafer coated with sputtered silicon dioxide, maybe like 300-400 nanometers. Yes, and the pump is doing great. Now it has like almost 300 hours of continuous use. It's water cooled at this point, like doesn't heat up, like pumps really well, and so on and so forth. So I guess here you go. Expect more videos in the future, because in the future I mean in the new year, because well, my thesis defense is in a few months. So when I'm done with it, I will be uploading all the videos I have filmed in a while. So here's that. See you later.